Poland. I'm a product manager for OpenStack here at Canonical, but I'm also helping with other parts of our data center business. I've been with the company for 8 years, and I've been with the OpenStack community since the Icehouse release, which was almost like 10 years back. So it's been a long journey so far.
Cool. Thanks. Thanks, Titus. So should we get started? I think Titus is going to introduce private clouds. I have one.
Absolutely. So we're going, as Rob mentioned, we're going to talk a little bit about the benefits of a private cloud over a public cloud to start with, which is a very interesting topic because if you think about that, we're obviously surrounded by public clouds, like from all the sides around us, right? Like you can easily create an account on AWS or Azure or Google. You can attach your credit card to the billing system and you can start provisioning resources from your cloud provider almost immediately. And this is usually the most convenient way to get started with cloud computing for any types of businesses, right? But at the same time, private clouds remain relevant and they are still in the game. And it's because of some very valid reasons, right? So we're going to talk briefly about those reasons for now. So there's if you go with public clouds, it usually comes with a number of challenges that might not be immediately visible for you, but most of the commercial organizations start realizing those challenges sooner rather than later, right? So the first challenge you're likely going to cope with will be the overall total cost of ownership, right? So public clouds are simply known from being expensive, right? Like, and then they appear to be relatively cheap, right? Like, because you get the pay-as-you-go billing, right? Like, you actually pay just for the amount of resources that you're consuming, while running your own cloud obviously comes with some significant investments that you have to make, right? Like you have to purchase the hardware, you have to install it, you have to put it somewhere in the data center, you have to pay the ongoing bill for electricity and cooling and data center maintenance and so on. However, the challenge here is that once you once you run more and more workloads in public clouds, and once you start running them in the long run, it all of those small costs aggregate, and you end up paying a significantly high bill, right? So usually there's a point where it basically becomes more economical to set up your own cloud environment rather than renting resources from the public cloud service provider, right? So TCO optimization is usually one of the reasons organizations decide to start their journey with private clouds, and it's most obvious reasons and the most common one. However, in these interesting days that we're living in, right, there's another challenge that a lot of organizations start dealing with, which is digital sovereignty. This is how we call it, right? So if you think about that, a lot of organizations these days start awaking themselves to a fact so that their data that they put in public clouds are not really secure, right? Like at the end of the day, no one knows who gets an insight into this data and how those confidential information that are stored there um, used by the cloud service provider, by the operators running the public cloud, right? So this is a very valid reason to actually build your own cloud as well and keep your data confidential by always hosting them on-prem if they are confidential, right? Um, the other reason that we usually see that forces some of the organizations to consider building their own cloud is performance. This is especially relevant in parts of the world where all the leading public cloud providers do not necessarily have local data centers, right? So regions like Africa, Middle East, some parts of Asia, you likely won't see a local data center of Amazon or Google being available over there. So if you intend to run your business applications in a cloud and want to serve customers in your local markets, it might be a better solution to actually host your own data center and build your own cloud infrastructure, just to ensure high bandwidth and lower latency. So if we take a look at some stats that we can get from like leading analyst institutions, it is obvious that private cloud is still in the game, right? Like the world is undoubtedly moving to cloud computing, and cloud computing is a technology not just of the future, it's a technology of today. If we take a look at those stats, right? So 94% of companies worldwide are adopting cloud computing these days, right? Like it's everywhere. Every serious business is moving to the cloud these days, right? Or is already there, and it's just expanding the coverage of cloud computing across their IT infrastructure. But this does not mean public clouds only. So taking a look at the stat, like here in the middle, right, like 82% of IT decision makers have already adopted hybrid cloud strategy, right, which usually consists of both public cloud and the private cloud, and it's absolutely fine to use those two at the same time to kind of optimize the TCO, optimize your level of governance, right? Like it, public clouds provide more flexible resources. Private clouds provide cheaper resources and resources that can be safeguarded. So it's fine to adopt like a hybrid cloud model. And taking a look at the last stat here, right? So 45% of organizations use private cloud to host their workload. So it's not a majority, but it's still a significant percentage, right? So a lot of organizations all over the world use private cloud to host their workloads. So taking a look at some other stats that we can get from some other reports, it becomes kind of obvious that the world is also moving towards open source, right? Open source is everywhere, and a lot of organizations are already using it in production and are continually expanding the portfolio of open source products, software, and solutions that they're using to drive their business. So, for example, 99% of telecom decision makers do rely on open source today. It's like most of the telcos are powered by open source technologies already. 95% of companies increase their use of open source from 2022 to 2023. And out of all of those open source solutions, Canonical takes a pride to be the publisher and maintainer of Ubuntu, which actually is the most popular Linux distribution across any Linux distributions that are available out there. And this is not just in the desktop space, but it's also in the infrastructure space, right? So Linux historically has been this kind of a channel to open source, so that you can get like all the benefits of open source, all the goodness on Linux, which is open source operating system again, right? Like, and out of all distributions of Linux that are available out there, Ubuntu continues to be the most popular one. It continues to be the Linux distribution of choice. So what I'm trying to say is that it is important to have to keep those facts in mind when considering building your own private cloud infrastructure based on open source technologies, right? Because this is clearly where the world is moving and where every serious organization is moving or has already moved until now. So taking a look at the benefits that organizations can get from running their own cloud, like doing cloud computing their way, basically, right? Defining the way they do cloud computing in their organization is, first of all, clearly TCO reduction, which comes from the fact that owning an infrastructure is more cost effective than renting it, especially when running workloads in the long run and at scale. Regaining control over the data by storing the confidential data on an infrastructure where they have a full control on and they know those data are secure. Better performance by hosting, but by storing the data and hosting workloads on top of the infrastructure that is local to themselves and local to their end customers. Architectural freedom, which enables them to run their infrastructure on top of their silicon of choice, their hardware of choice, their basically set of technologies of choice, right? Which is usually not possible when, again, storing the data and running workloads in one of the public cloud providers. Increased flexibility, which stems from the fact that they can plug in their private cloud infrastructure into this broader hybrid multi-cloud ecosystem and benefit from using both at the same time. And at the end of the day, vendor diversity, right? So not being dependent on a single vendor in a public cloud space, but rather relying on a solution that is fully open source and backed by an entire open source community leads to vendor diversity and reduced lock-in. So this is how it looks like when we enter like the canonical world, right? So what you can see on this diagram is more like a whole portfolio of canonical infrastructure products that can be used to build like a production grade private cloud solution. It obviously starts on the hardware layer, right? So as the company behind Ubuntu, we certify leading hardware components that are available out there on the market and make sure that the solution works when deployed on top of it. And then when it comes to various pieces of a software that we use, they're usually we use the best of breed technologies that are available out there on the open source market. Sometimes we consume the software that is produced by some upstream communities. Sometimes we produce the software ourselves. So again, starting from the bottom up, MAS is an essential piece of a software that automates all machine provisioning processes in a data center. So when you request machines to be installed, configured on demand, MAS is basically this piece of a software that automates all of those processes. Then we use Ubuntu server on top as the operating system, of course, a landscape which can be used for the purpose of system management at scale. And then a number of infrastructure management components. And again, we use the best of breed technologies that are available out there. So this includes LXD and KVM for the purpose of driving compute resources, Ceph for the purpose of driving storage resources, and OVN for driving anything around networking. What we can put on the top is either microcloud, OpenStack, or Kubernetes, which actually create the ultimate cloud management and orchestration layer, where all of the resources that are provisioned by those technologies used underneath can actually be exposed to an end user in a form of a self-service portal, right? So the user can request resources on their own and get them provisioned in a fully automated way. So when it comes to choosing the right technology to actually provision resources, it usually ends up with a choice between Canonical Microcloud or Canonical OpenStack. Excuse me. So whereas Canonical Microcloud is usually a better solution for running small scale private cloud infrastructure, when it comes to implementing more sophisticated solution like a data lake, for example, Canonical OpenStack usually provides a broader flexibility, so is a better fit. So if we take a look at how its underlying architecture looks like, it obviously uses mass again for the purpose of bare metal automation. And then OpenStack is this piece of a puzzle that provides infrastructure as a service capabilities. So it allows end users to provision virtual machines on demand. And then on top, we can put Kubernetes, which can serve as a foundation for running all of the data lake solutions, right? So all the applications, including Spark and so on, that actually create a data lake solution can be put on top of Kubernetes. And Juju provides the workloads orchestration layer that enables those services to be deployed and operated in a fully automated way post-deployment. A good thing is that this whole stack is covered by a single Ubuntu Pro subscription that includes security maintenance and support with guaranteed SLAs. That's available for commercial customers. So this all ensures production grade stability and allows running it for very much sophisticated use cases. The whole platform is highly performant and enables people to get 100% from their hardware. So first of all, it includes all the typical EPA features that are usually required for the purpose of running compute-intensive workloads. It also supports GPU virtualization, which is again something that compute-intensive workloads usually require, as well as DPU hardware offload, which can effectively free up CPU cycles on a host by basically putting either networking or storage components on DPUs. So on a piece of a silicon that's actually fully external to the host. And if you take a look at this kind of a triangle between a CPU, GPU, and DPU, this is most likely how a data center architecture of the future is going to look like. So it's no longer just CPU, right? We try to be at the forefront of this technology shift, and we're proud to be a contributor of some pioneering solutions in this front in the upstream OpenStack community, especially when it comes to DPU hardware offload. The platform ensures interoperability across the various silicons, hardware, and storage, again, to enable you to build a cloud your way and regain like a full architectural freedom. So first of all, we support all leading cloud architectures, including the hyperconverged architecture that we promote as the one being the most cost-effective. That's at the same time, we also fully support converged and fully disaggregated architectures. On the silicon front, we work with all the leading silicon vendors to make sure that the solution is fully tested and validated on the top of those architectures. On the hardware side, I mentioned that when talking about the certified hardware. So it's the same story. We work with the leading IHVs to make sure that the solution is fully compatible with their hardware. And on the storage front, we promote Ceph as the software-defined storage solution, but we also support some other storage solutions. Integrations are possible, so it all depends on the use case. Now, talking about running it in production, the good thing is that Canonical OpenStack comes with like a fully predictable release cadence that is tied to the Ubuntu release cadence. Every version of OpenStack is available with fully automated upgrades, so customers can benefit from the new features, the bug fixes, and all the improvements that are brought in the new OpenStack versions by simply upgrading to newer versions. But at the same time, every 2 years we ship so-called LTS releases of Canonical OpenStack that come with 5 years of commercial support and 10 years of security maintenance, enabling commercial customers to run them in production for long without upgrading. So they can always choose, right? Like they can easily upgrade to newer versions in a fully automated way, or they can stay longer on some old versions if they prefer stability over anything else. Moving to the next slide, the real cost effectiveness of the solution comes from the full bottom-up automation that we're using underneath. So I mentioned mass as an essential component of every canonical solution in the infrastructure space that automates all machine provisioning processes from like an initial request through like operating system installation, configuration, and then providing it back to the user in a form of a bare metal resource that has been installed and delivered according to end user needs. And on the other side, we use Juju and Charms, which automate everything that's in the software space, right? So they take care of automating the deployment of OpenStack, but not just OpenStack. They also provide exactly the same capabilities for Kubernetes and Spark. So the whole stack is actually backed by Juju and Charms for the purpose of the initial deployment and its post-deployment operations automation. So at the end of the day, it all turns into less overhead on the operations team and time savings that organizations can benefit from when choosing the canonical stack. The whole platform has been proven to work successfully and across various market sectors and in various parts of the world. So the case studies that I'm listing here have been chosen by me very deliberately because they answer like those three challenges. Like each of them answers a different challenge that those customers have been facing with when using other cloud technologies or some traditional proprietary virtualization technologies. So we talked about TCO optimization and challenges with TCO when running workloads in public cloud. So this is something that's very much relevant to one of our customers, Zicredi, who have seen TCO benefits from using Canonical OpenStack over public clouds. I believe 2 to 3 times TCO reduction. UniCC is a different example. It's an example of a customer who's built their own cloud because of the digital sovereignty concerns, right? So they wanted to have a full control over their infrastructure and over the workloads and data being stored there. And they were successfully able to do that by using Canonical OpenStack in production. And Telecom Networks Malawi is like this kind of an example of a customer who runs in a part of the world where there's no local public cloud data center available there. So they're a telecommunication service provider that's based in Malawi, Africa. And again, they've been successfully able to build like their fully operational production, their own cloud by using the Canonical stack of technologies. So that's all from me for now. Apologies for a little bit challenges that I've been facing when presenting that. Now over back to you, Rob.
Okay, well, let's see. I may have some myself. You never know. Thanks very much, Titus. That's a great overview of what a private cloud is and why you might want one. I'm now going to talk about like building a data lake on top of private cloud technology. So I'll talk a bit about that, and then we'll get to your questions. So next slide, please. So first of all, well, what is a data lake, right? We need to be on the same page about that. So a data lake is essentially a repository, a service environment that can store structured data, semi-structured data. So structured data is, for example, relational data from a database. Semi-structured data might be things like XML or JSON documents, and unstructured data, so things like photographs or video clips or audio clips. These are all different kinds of data that you can aggregate into a data lake and process with the appropriate tooling. So the purpose of aggregating that data and processing it is, well, typically you're using it for either business intelligence use cases, so building reports and dashboards and health checks, whatnot. Data science and analytics, so doing kind of data discovery, perhaps doing geospatial analysis on a data set to discover new aspects of your business that you didn't know about before. Last use case for a data lake is typically building a kind of repository of knowledge with which to train artificial intelligence or machine learning models. So those are the kind of the three major use cases for a data lake. And that's the kind of the concept behind it. So we can move to the next slide, I think. Yeah, so the kind of components of a modern data lake. So historically, data lakes were all about Apache Hadoop. That was the kind of de facto choice for building a data lake. Of course, Hadoop is a great tool, but it has some challenges here and there. And then the world's kind of moved on a little bit. So there are alternative choices, but essentially the building blocks stay more or less the same. You have at the heart, you have distributed parallel data processing. So what this means by distributed in parallel is that the data processing takes place across many servers at once and at the same time. So distributed across many servers and running at the same time, so that the servers are cooperating and working together to process your data in an efficient, time-efficient manner. So if you have multiple terabytes of data that you want to process, if you're going to process it on one box, it might take several hours or several days. But if you have maybe 50 or 100 servers all working together to process the data in a coordinated way, you can bring that down to hours or minutes, or even seconds in some cases, depending on how optimized the setup is. And the nature of the workload. So that's the heart of the modern data lake solution. Underpinning that is some kind of object storage system. So with Hadoop, the data was aggregated together with the compute. So the two were kind of locked together in this kind of converged architecture. Now, with a modern solution, typically you're kind of disaggregating that. There's good reason for that. So when Hadoop was developed in 2006, 2007, network costs were network capacity was extremely limited within the data center. You'd be lucky if your data center had 1 gigabit Ethernet, quite honestly, at that time, although it got better with time. Nowadays, data centers typically run 100 gigabit Ethernet or 250 gigabit Ethernet or more. And so, you have massively more capacity. So the need to, bring the compute to the data is less so now than it was, 20 years ago. So it makes more sense to disaggregate the data from the compute because you can manage them separately, you can scale them separately, and you can treat them separately. You have different processing and different rules around how you handle these two compute resources. Lastly, we have at the top there some kind of query service is kind of a commonality that we tend to see. So in the Hadoop days, that would have been something like Hive or Impala. So there's still tooling that allows you to do that kind of large-scale SQL querying of your data, but not necessarily using Apache Hive. And then lastly, some kind of analytics tooling is kind of essential to be able to make, the most of your environment. You need some kind of user interface within, some kind of way to work with your environment. So I think we can move on to the next slide where we try to map this out. So in a modern data lake, running on a private cloud, for disaggregated storage, you'll be using something like Swift on OpenStack. So Swift it's kind of like AWS S3, except in your private cloud that you have under your own governance. So it's also a very high scale storage system, or it can be, depending how it's set up. It also has it can be set up with very high, what's the word I'm looking for? Redundancy, so that you don't lose your data, basically. Durability, that's the word I was looking for. Very high durability guarantees. And it can be set up for great performance too, with tiered storage, so that you have a cache for data that's in the working data set stored up perhaps on NVMe or flash storage, and then your long-term cooler data sets stored in spinning media. So you can have a cost-effective but very performant storage system that you run within your own data center through something like Swift on OpenStack. But the distributed parallel data processing core, nowadays we recommend Kubernetes as your kind of cluster resource manager with Apache Spark, which is, Spark was the kind of one of the most popular of the runtimes with Apache Hadoop, and there's nothing wrong with it. So, we take it forward into the kind of next generation of the data lake technology. But in this case, we're running it on top of Kubernetes instead of on top of Apache Yarn, which was part of the Hadoop distribution. So why would you do that? I think the benefits are, well, Kubernetes is just so much more powerful. For one thing, it's an incredibly flexible solution, has a kind of plug-in architecture for things like networking implementations and storage implementations for the local components running. Another benefit of running your workloads on Kubernetes is that you can also deploy other applications that your system might need to the same environment. Kubernetes is very much oriented towards kind of multi-purpose application execution. You can run any kind of application on there. So it means that you can have adjacent components or supporting components also running on the same cluster under the same kind of operating principles and under the same governance. Now at the top, so for a query service, nowadays we're recommending Apache Kyubi, which is a kind of replacement for Apache Hive. So Kyubi will act as a kind of gateway that you run on your cluster. It's scalable, horizontally scalable, much like Apache Hive, Hive Server 2. So it gives you the ability to send your SQL queries to like a web farm of query servers, which will then translate those SQL queries into Apache Spark jobs, which run on your Kubernetes cluster. That's the kind of the architecture. Lastly, for analytics tooling, the most popular tool these days is Jupyter, without a doubt. So Jupyter is a data science notebook environment for authoring your Spark applications, and just using for like real-time REPL looping of interactive queries of your data sets for example, data science use cases or analytics. So if we move to the next slide, so I've mentioned some of the kind of benefits of running a data lake on a private cloud already, but I wanted to go a little bit more deeper on that. So I think the obvious benefit is simplification, actually. So versus running on just a bunch of bare metal servers or running, so first of all, I'm going to analyze it from the perspective of running on premise. So on a bunch of bare metal services, and then we'll look at the public cloud versus private cloud. So if you're running on a bunch of bare metal servers, some of the disadvantages to that, well, one is that you're not using virtualization, which might sound counterintuitive. Everybody knows that virtualization comes with some performance overhead, but you get some benefits too. So one of the benefits is that you have an additional layer of security around your applications. So all of the device drivers are virtualized, for example, so that it's much harder to hack a VM actually, or to break out of a VM and hack a hypervisor than to hack a bare metal system. So you're getting a significant security benefit through virtualizing your applications. Another benefit of running your data lake on a private cloud system is that you can set it up in a multi-tenant manner much more simply, because you basically you're going to have a push to deploy Kubernetes environment per tenant, so per user or per organizational unit, rather than having to try to go into the weeds and sort that out at the Kubernetes level, using service accounts and separating it kind of soft boundaries. You can use a more delineated approach by using the cloud itself to actually enforce those kind of multi-tenant boundaries. You can do the same with the storage, so that you have your storage system, your object storage, Swift system, divided into user spaces for your tenants. So it's an obvious benefit of using a private cloud over doing it on bare metal. There's no kind of downside in the sense that you can still deploy Kubernetes on top of your private cloud, so you're still getting the benefits of Kubernetes. I only really see upsides to this approach. Okay, so other benefits, perhaps versus public cloud. Well, in the hardware aspect, you can provision GPUs very cost effectively, versus on public cloud at the moment. Anyway, GPUs tend to be quite a pricey resource. Then you can also use high performance technologies like InfiniBand, which is an alternative to Ethernet. So it's an alternative networking stack that gives very high performance. And Spark can actually use InfiniBand with some extensions, so that you get the benefits of running your Spark jobs across the kind of InfiniBand network fabric or dual fabric with Ethernet as well. This can be very helpful, for example, for streaming data between executors for the shuffle operations of Spark. You also have RDMA, remote direct memory access. That can also be something that you set up on a private cloud, which you might struggle to do on the public cloud. Okay, so moving on to cost. So obviously, costs are going to be much more predictable on a private cloud environment versus pay-as-you-go public cloud. The costs can be a little bit hard to calculate sometimes, and a little bit unpredictable. It's also like for a very large scale deployment, when you're talking about hundreds of servers or even thousands of servers, the costs are a lot more scalable if you build it on premise. That's not to say that there's anything inherently wrong with public cloud, or doing cloud bursting, for example, to pass workloads over to a public cloud when you're hitting your capacity limits in your private cloud. But I think from a kind of, if you're serious about building a data lake, it's much more scalable from a cost perspective to do it on premise with a private cloud setup. Okay, then the last, so Titus mentioned it, but data sovereignty is a concern for many. So there's the privacy aspect, but there's also the kind of lock-in aspect. So privacy is like sensitive workloads, for example, state secrets or whatever, probably don't want to dump them into a cloud. But a private cloud might make more sense. But there's also things like lock-in. So lock-in is where you're kind of tied to a cloud service provider because you used only their services when you built the environment, and now you can't exit anymore because it would be too much work, too much rework to rebuild the system on another public cloud provider or on a private cloud. It becomes, kind of anti-pattern of cloud computing to do that actually, because you're setting yourself up for failure in the future, or you become a hostage to fortune in that sense. And then lastly, with a private cloud, there's obviously no egress fee. So what is an egress fee? An egress fee is where when you choose to take your data out of the cloud, out of the public cloud, they charge you a fee. So if you have like 10 gigabytes of data, a fee is trivial. I mean, like you're not even going to notice it. But when you have 3 petabytes of data, it's significant. Like it's discouraging to move your data out of the public cloud when the egress pricing cranks up like that. So it's another kind of anti-pattern of data lake design. Okay, I think we can move on to the next slide, which, as I recall, is how Canonical can help you. So I mentioned that, well, Titus mentioned that we have our OpenStack solution, which is, an enterprise, carrier grade, an enterprise grade solution for building private clouds based on open source software called OpenStack, and it's designed to really scale. So you can build systems with thousands of nodes, with petabytes of storage, appropriate for a data lake, using that as the foundation. The other thing that we can help you with is our Spark solution. So Spark is the most popular big data processing runtime today, I'd say, with that question. And this is a solution that we've built around Spark that allows you to deploy a service environment for running Spark jobs in an optimal way with monitoring and alerting and automation. It's just a nice solution. It runs on Kubernetes, which is also a thing that we can help you with. So we provide a full stack, so you can have the private cloud, the operating system that Ubuntu, and the data lake runtime, all from us as a kind of one-stop shop. So that brings me to the services. So we can help with the design and setup of such a site. We have a very experienced field services team that are more than capable of doing this kind of work. We also have a very strong support organization, which is extremely experienced in supporting open source software of all kinds, but especially so in the private cloud and big data stuff. And we offer both weekday support and 24/7 support for your production environments, your mission critical environments. And then lastly, we offer managed services. So if you don't want to have the hassle of managing these environments, you want a cloud or you want a data lake, but you don't want to have the hassle of managing it, we have a managed services team that can operate your carrier grade cloud for you if you want that. I think that's it, Titus, if I check through the slides. So it's time for questions. And I see that we've had some. So Titus, do you want to answer this one? What's the difference between a private cloud and an on-premise server?
Sure. So I think we know the answer, right? But what's the? I think the real question behind is like, what's the benefit of running cloud on-prem rather than using like a traditional IT infrastructure, right? So there's a number of benefits stemming from adopting the cloud computing paradigm. It's like cost optimization, runtime, resource optimization, more flexibility. You can empower your teams to provision resources from this infrastructure on their own through like a self-service portal or APIs. You can automate those processes. So there's a number of benefits, right? Usually the cloud computing paradigm is considered right. This is a technology not just of the future, is a technology of today. Everyone is moving to the cloud because there are a number of benefits. There's
Cool.
another one I can cover, which is about what tool would you recommend for OS baselining to align with our company's CIS baselining? So as a part of the Ubuntu Pro, what's included is our compliance programs, which also help organizations to align with this kind of hardening profiles, like CIS or DISA-STIC, for example. So when using Pro to power your private cloud infrastructure, you get an access to those profiles that are natively available, so that you can make sure that the whole infrastructure is hardened to comply with those regulations.
Cool. I can see some more questions coming in. So they're more about the data lake side of things, so I'll have a go. When should one choose between different data lake solutions like Delta Lake, Apache Iceberg, and Apache Hoodie? At the moment in our Spark solution, we have support for Apache Iceberg integrated out of the box. So we would recommend using Apache Iceberg. However, some customers prefer Delta Lake. It's really down to preference. These are the most mature of the two. I'd say Apache Hoodie, personally, I find less mature. We may take a view on Delta Lake in the future, no commitment there. But today we offer Iceberg. So what do these things do? So Iceberg and Delta Lake and Hoodie, they're basically providing you with a storage engine, effectively, for doing things like in-place updates or in-place deletes within a data file. So if you have, for example, the GDPR, I don't know if the audience knows that, but it's the General Data Protection Regulation in Europe. It means that people have the right for their data to request that their data is deleted by a data processor. And if you have a data lake with files that are terabytes large, and you have to go in and reprocess those files to delete that user's data, it's non-trivial. It means reprocessing very large data sets can take some time. So something like Apache Iceberg allows you to literally just go zap that record, and the record is background. A delta is built of the file set, and background merged using background processing, so that the record is immediately removed, but the kind of settlement of that process is done asynchronously. So that's what those solutions do. And like I say, so we have Iceberg pre-integrated and out of the box and supported. I should also mention that our Spark solution comes with 10 years of support per release track. So that's worth bearing in mind as well. So even long after the Apache Foundation have said no end of life, we'll continue to support it. So we'll continue to fix security vulnerabilities and provide professional support around those Apache Spark releases. I think there's another question. What are the advantages of using Doris. Apache Doris is a data analytics platform on top of Apache Spark. So we've gone a different route for now, which is using Kyubi, Apache Kyubi, as a kind of SQL gateway, so that you're having a very similar experience to Apache Hive. This means that cutting over from Hadoop is relatively painless, because the user experience is very similar. That's why we've chosen that approach rather than the Apache Doris approach. Although who knows in the future what we might adopt. It's also about kind of maturity, kind of solution maturity. We tend to go with best of breed software, so that's why we've taken that path. Yeah. Okay. I think that's everything.
There's been some questions about people not being able to see the slides. I've checked in the middle of our talk so that our slides are actually coming out on the audience side. So what I can do is to encourage you to try to watch it on demand. It will be available on demand later on. You can also reach out to us directly if you're interested to going with us throughout this content. You can. There's a contact form at the Ubuntu and Canonical website that you can use to get in touch with us directly.
Yeah, and we'd be happy to get on a call with you and discuss your needs. All right, I think we're more or less at the top of this talk, so it's been great. Hosting it. It's been a lot of fun, and yeah, see you on the next one.
Thank you very much for listening to us.
Take care and have a great day.